Greetings, my beloved viewers. I remain your physics teacher, Mr. Okafor PC. Today, our topic of discussion is physical quantity or physical quantities. However, recall, physics is highly concerned with nature. Nature comprises of matter, energy, forces, time, etc. If nature comprises of matter, therefore physics has interest in matter. Today, in order to discuss the topic physical quantity, we need to understand how it relates to matter. In order to understand matter, we need to identify various parts in matter, various properties of matter. And to identify various properties of matter, we'll be talking of physical quantity. It will be difficult, or rather impossible, to study matter as a whole at the same time. Therefore, we need to put matter to different parts. We need to identify various properties in matter, then study those different properties of matter. And this is what we call analysis, taking matter into various parts. After making research at various parts of matter, we can now put them together. This is what we call synthesis. In order to see various properties of matter, we have to call them physical properties. Why? Physical, because we can see them, we can lay hands on them, we can do experiments with them. Physical, things we can see, feel, and touch. Physical properties. So properties, those properties in matter that we can measure are called quantity. They can be quantized, they can be measured. So physical quantities are different properties of matter that can be measured, that can be studied, that we can come up with findings. There are various properties that can be measured in matter, numerous of them. And in order to understand these various properties of matter that we can measure, that we can study, we put them to two categories. We have two types of physical quantities. One, we have fundamental physical quantities or fundamental quantities. Two, we have derived physical quantities or derived quantities. Recall, a quantity is a property in matter that can be measured, that can be studied. We can't tell every aspect of a matter at the same time, so we need to take them to various parts. Analysis, physical properties, physical quantities. When we come to fundamental quantities, what are fundamental quantities? Fundamental quantities are those properties in matter that are basic in every matter. All matters must have it. That's why it's fundamental. Basic properties in all matters around the universe. The basic quantities in all matters around the universe are called fundamental quantities. They are fundamental. They are basic. They are primary. Every matter must have it, be it solid, liquid, gas, plasma, Bose-Einstein condensate. All states of matter must have it. That's why it's fundamental. Fundamental quantities. And they are 8 in number. Number 1 is mass. Number 2 is length. Number 3 is time. Number 4 is electric currents. Number 5, temperature. Number 6, amount of substance. Number 7, luminous intensity. Number 8, magnetic flux. Do not panic. Do not panic. We will take them into parts for easy understanding. Recall, fundamental quantities are those quantities that are basic, that must be found in every matter. Let's start with mass. Mass. Every matter has mass. All matters are comprised of particles. Particles. And number of particles in a body or matter is what we call mass. Number of particles in a matter is what we call mass. Let me give you a clear example. If we have two students, two science students that have the same school bags, and one has 7 textbooks, let's say the same textbook, mathematics textbook, the same textbook, one has 7, another has 14. The student that has 14 same textbooks has a greater marks. The school bag has a greater marks. The number of particles in a body is what we call marks. Here, the number of books in the bag is the marks. 14 books makes a greater mass compared to 7 books. Every matter has mass, but the masses differ. The more particles you have, the more massive you are. The number of particles in a body is what we call mass. All matters have mass because all matters are comprised of particles. That's why mass is a fundamental quantity. Number 2, length. Every matter has extension in space. All matters occupy space. How much you extend in space is what we call length. Some matters have longer length, some others have shorter length, some others have infinitesimal length. Very small length that we can't even see with the naked eye. Example is an atom. Everything has length, extension in space. Number 3, time. All matters have time. That's why time is also fundamental. Time. Only science scholars are very much aware that time is synonymous to motion. The concept of time is the concept of motion. Take for instance, 24 hours is the rotation of the earth around its axis. 1 year is the revolution of the earth around the sun's orbit. So time is synonymous to motion. All matters are made up of particles, and the particles are in constant vibration, and vibration is motion. That's why I have other smaller units of time. Microseconds, milliseconds, picoseconds, and thereabouts. All matters have time. They vibrate. Let me shock you. Are you aware that you have time in you? The heart beats. The heart beats in humans. It's time. It's time device. And what makes time unique is that it must be synchronous. It must have synchronization. It must have equal pattern. Equal pattern. That's what makes a better time. Time should have equal pattern. 60 seconds make 1 minute. 60 minutes make 1 hour. That should be kind of synchronization. The heart beats 72 times in every 1 minute. 72 times in 60 seconds. That is time. That's a perfect time device. The human heart. Even humans have time. That's a proof that time is fundamental. Humans have mass. A proof that mass is fundamental. Even humans have length. All matters have mass, length, time. It didn't end there. Number 4 is electric currents. All matters have electric currents. Currents are caused by tiny particles called electrons, and they are charged particles. Since all matters have atoms, they also have electrons found inside the atom, at the orbits of the atom. All matters have electrons, therefore all matters have electric currents. All matters, be it solid, liquid, or gas. Temperature. All matters have temperature. That's why it's fundamental. Temperature is the average kinetic energy in a body. Since all matters have particles that are in constant random motion, the constant random motion attributes the existence of temperature. The more the constant random motion, the higher the temperature. The less the constant random motion, the lower the temperature. So the average kinetic energy of these particles, tiny particles in matter, is what gives us temperature. The degree of hotness or coldness of a body or environment, temperature. All matters have temperature. Amount of substance, another fundamental quantity. If there are particles, there will be amounts. This word differs particle. A matter may have smaller number of particles, another matter may have bigger number of particles. This amount of substance. All various matters comes in various amounts. That's why it's a fundamental quantity. Fundamental quantity, amount of substance. Another is luminous intensity. Luminous intensity. Listen to the word. Luminous, light, intensity, level. All matters are stars. Stars we are. Everything is star. Everything is emitting light. Believe it, everything is a star. There are different kinds of lights. Don't be confused with one type of light or one form of light called visible light. Visible. We have 7 categories of lights. We have 7. We have radio wave. We have microwave. We have infrared, we have visible light, we have UV light, ultraviolet light, we have X-ray, we have gamma ray. Every matter is emitting light because light comes from atoms, and atoms are tiny particles in all matters. Take humans for instance, we emit light called infrared. Snakes are away. Snakes are very much away. Dogs are very much away. That's why in police force or in forces, security forces, they work with dogs because dogs can smell the light, the infrared. If you like, be hiding anywhere. When dogs want to find it, they can easily find it because they're emitting light. You have touch around the body. Even in darkness, dogs can locate you and begin to bark. Police come after you. So if you're a criminal, you're running at night time to escape police force, it's better you continue running. When you stay at a corner to hide, you're just wasting your time if there's a nearby door or if there's a police door. Dog can easily go and find you because you're emitting light. Just like somebody that has stolen and you're putting light on your head as you hide. the dog will locate you. It will expose you because you're emitting light called infrared. Likewise, snakes, they can sense that light in infrared. So those of us that do bush method in villages, you understand better what I'm saying? When you're inside the bush, you can easily attract snake because when you are hot, you emit more infrared. And snakes can easily locate you and give you one or two. Yeah, that's why when snakes want to eat, even other animals emit infrared. The tongue begins to function most because the tongue is a sensor. The tongue of a snake senses infrared. Even when you tie the eyes of the snake, it can easily locate someone because it uses the tongue to sense infrared coming from animals or prey, even humans. So everything is a star. We emit lights. That's why luminous intensity is a fundamental quantity. Nothing is void of it. The magnetic flux is another fundamental quantity. Anywhere there is electricity, there is magnetism. Anywhere there is current electricity, there is magnetism. If electric current is fundamental, magnetic flow is also fundamental. Do not panic. Some of these words will still get them simplified in the future course of this training. So no panic. These are science terms and will demystify their nature. Recall, fundamental quantities must be found in all matters. And this is why they are fundamental, basic, or primary. I will take them back again. Number one, mass, length, time, luminous intensity, electric currents, magnetic flux, amount of substance, temperature. We don't mind the order, although we give special preference to the first three: mass, length, and time. With time, you will know. Okay. In science, you are very much concerned with appropriate measurements. You cannot give appropriate measurements with quantities only. We need to know the units of this quantity. What do I mean by units? For instance, if I ask you how old are you and you say 12, 12 can mean anything. 12 can mean anything. The information is not yet complete. It can be that you are 12 years old. It can mean that you are 12 meters tall. It can mean that you have 12 bananas. It can mean that you have 12 biscuits. It can mean anything. 12 is not a proper measurement. So when I ask you how old are you, I want to hear something like 12 years old. Yes. It makes the information complete. And I know what quantity that has been measured, or I want to measure, or you've told me, or you've measured yourself. 12 years. 12 there is number. Years there is the unit. Spicing the number. So 12 years is now age, quantity. So the age there is the quantity, while the years is the units, and that is appropriate measurements. Every measurement should have a quantity, then followed up by units. So if a property in matter is called fundamental quantity, so that fundamental quantity will be followed up with fundamental units. Fundamental units. These are the spices of measurements. For example, mass. The fundamental unit of mass is kilogram. Fundamental unit of length is meter. Fundamental unit of time is seconds. Fundamental unit of electric current is ampere, in honor of a scientist whose research on electric current cannot be ignored. Andre Marie Ampere. In honor of this great scholar, the unit of electric current is ampere. The unit of temperature is Kelvin, in honor of Lord Kelvin. The unit of amount of substance is mole. The unit of luminous intensity is candela, Candela. The unit of magnetic flux is Weber. Magnetic flux is Weber. While magnetic field is Tesla, in honor of Nikola Tesla. Yeah, these are fundamental units. Okay. Then we won't just rely on fundamental quantities only. There is also need to do manipulations of what we have. And that will take us to derive quantities. From the name, you can know what I mean by manipulations. Yeah. When we get two lengths and merge them together, we get a new quantity called area. Derived quantities. They are those quantities that are manipulated from fundamental quantities. When you mix up fundamental quantities, you get new quantities called derived quantities. For instance, when I get two lengths I'll form area. When I get 3 lengths, I'll form volume. Therefore, area and volume are derived quantities. There are so many of them. We have weight. Weight is derived from mass. When you get mass, then get acceleration due to gravity. We know what the term means. Mix it up. Acceleration due to gravity. You will get derived quantity called weight. We have so many of them. We have speed or velocity. Speed of velocity. Get distance and get time. Form a ratio of the two. You get velocity or speed. With time, we demystify the formulas. No panic. We have discussion on formulas and how they were derived. They didn't fall from heaven. They were derived. So speed or velocity is derived quantity. Acceleration is derived quantity. Pressure is derived quantity. Momentum, derived quantity. Density, mass over volume. Density, mass over volume. Density is equal to mass over volume. Derived quantity. Work done, derived quantity. Work done or work. Power, derived quantity. So these are simple manipulation of fundamental quantities, or even manipulation of fundamental quantities with derived quantities again. We'll give you derived quantity. And the units of measurements in derived quantity are called derived units. For instance, area is mixing 2 units of length again. Meter times meter to give us meter square. Volume, meter times meter times meter. Because volume is length times length times length. 3 dimension. Length, length, length. L cube, mm, meter cube, unit of volume, meter cube. Or other subunit like centimeter cube. Other subunit like centimeter cube. Area, length times length. M times M, meter square, unit of area, meter square. Speed, meter per second. Because speed is gotten from distance and time. Distance over time. Distance is meter. Over, per. Time is seconds. Meter per second. No panic. We'll still explain these formulas and their units. I just want to give you a clearer understanding of physical quantities, the divisions, fundamental quantities, derived quantities. I believe you now know why we study physical quantities, because physical quantities are properties of matter, and matter is found in nature, and nature is the concern of physics. So to study nature, we need to start from somewhere, and when we get to somewhere, we need to get the somewhere into parts. When we get to the part, we need to make in-depth study of that part. Make in-depth study of a particular property of matter, analysis, after which we now come up with synthesis. My dear scholars, I believe with the little thing I've said so far, you now know the meaning of physical quantity. You can now make the divisions, fundamental quantities, derived quantities. You now understand that the units is essential to every measurement. In measuring any physical quantity, there is need for units. We don't joke with units because it makes the information complete. And I also believe you know the fundamental quantities and their units, likewise the derived quantities and their derived units. Thank you. Stay tuned as we move on this great journey of understanding physics and nature better. Thank you.